Good morning, good evening, good afternoon, wherever you may be watching this from. This is Konyas Levinda with another segment of videos. This is video number 11. This video is going to be about vectors in two space or two dimensions. So I'm not going to look at vectors in 3 dimensions because that is looked at under A levels. So I'm going to look at vectors in 2 dimensions. First of all, you need to know what we call the slope-intercept form. When an equation is in this format, y is equal to mx plus c, this is called the slope-intercept form. That is called the slope-intercept form. Now, under vectors, we look at equations in this type of format. Negative 3x plus 6y minus 30, which is, for example, this equation should have been written as 6y is equal to positive 3x plus 30. Then we divide by 3, by 6, and by 6. We would get y is equal to that half x plus 5. So this is the slope-intercept form when an equation is in this way, or the gradient-intercept form. Now, under vectors, we want to look at an equation in this format. This is ax plus by plus c is equal to 0. And this is called the scalar equation. This is where you would, because the equation is in this format, you would take it in this format where all the variables, which is x and y with their constants, are there together with the constant c, whichever number that would be. You take it that side, to one side of the equation. Ax plus by plus c is equal to 0. So if we were to expand this, it would be taking a different format, which is 2y. For example, if we expand this, it would be 2y is equal to x plus 10. Then in the scalar equation form, it would be x plus this 2y is going that side. So let's just say minus 2y plus 10 is equal to 0. So what I did is just, the lowest common denominator was 6, multiplied throughout, multiplied throughout by 2. This gave us 2y plus x plus 10 is equal to the 0 there. Then now I made it substitute the formula like that. Rather, I collected like terms, So it became x minus 2y plus 10 is equal to 0, collected like terms. Now it was in the form that is called the scalar equation. Very important. So, here we have to know a few essential things. A position vector is represented by a letter, then with a small letter O there. So there is letter O there, which this is called R0. A certain position vector R0 can be equal to x, y. And then we have a resultant vector R, which is also equal to x, y. So the resultant vector comes about like this. R0 is the resultant vector is equal to R0 plus. We've got to have a certain direction vector. So what is this resultant vector? This resultant vector helps you get the next coordinate, R0 plus a certain direction vector. Now this direction vector is not always fixed, therefore there is the letter t. This t is called a parameter. So a certain parameter t, this means r would be equal to r0 plus direction vector S. Now this S can be substituted by T multiplied by direction vector M, which means resultant vector R is equal to R naught plus T direction vector M. Alright, so everything I've said here might be confusing to someone, so I'm going to explain that in the next video. This video is meant to introduce us to the format of writing a scalar equation like this. Negative 3x plus 6y minus 8 is equal to 0. So writing an equation in this form is called the scalar equation. Then this is what we call a vector equation. This is called a vector equation. Thank you so much for watching. This has been Konya Zubinda, and bye bye.